For the last, I don't know, 10 years or so, the richest companies on Earth have been trying to solve this one highly specific math problem.
Right. And they've been throwing just literally billions of dollars at it.
Yeah, exactly. I mean, they built these massive data centers the size of small cities, right? They bought up like every single computer chip they could possibly get their hands on, and they've hired the absolute brightest minds on the planet to just, try to brute force their way through this invisible wall.
Yeah, the brute force approach.
Exactly. And then out of nowhere, just last month, this completely unknown startup out of Miami steps up and calmly announces that they solved it in secret.
I mean, it is the ultimate disruptive moment, right? In any industry, really.
Well, absolutely.
Just that realization that an insurmountable barrier wasn't about a lack of brute force or, a lack of funding. It was simply not knowing the right combination.
Yeah. Welcome to today's deep dive. It is Saturday, June 20, 2026.
Yeah.
And we are looking at a development that currently has the entire technology sector, totally holding its breath.
It really does.
Our guiding source for this exploration for you today is a single, incredibly potent AI News Daily Digest. And this digest summarizes a breaking and honestly explosive report from the MIT Technology Review.
Yeah, and we are working with a very, very concise source today. But, I mean, the implications packed into those few paragraphs, they are massive.
Huge.
We are looking at a classic David and Goliath scenario here, just, played out in the realm of advanced algorithmic architecture.
Totally. So our mission for you today is to completely decode this audacious claim made by this newly emerged tech startup. We need to figure out what they supposedly did, why it has stumped the giants for a whole decade, and what it ultimately means for the future of the technology that you use every single day.
Because if this is real, everything about how we build and interact with software shifts entirely.
Right. Okay, let's unpack this.
Well, we have to start by looking at the origin story of the team making this claim, I think, because it really sets the stage for the entire breakthrough. We are heading down to Miami.
Right. And when you think of the Miami tech scene, you typically think of, flashy announcements, right? Bright lights, venture capital parties, crypto summits, all that stuff.
Oh, yeah.
It's a very loud, hyper-visible kind of culture down there.
It is. It's an ecosystem that really thrives on networking and, frankly, aggressive self-promotion.
Yeah.
You usually want everyone to know exactly what you are building, so you can secure that next round of funding.
Right. But amidst all of that noise, there was this one company operating in total, just absolute silence.
Total stealth.
Yeah. They are a startup named Subquadratic. And according to the digest, they operated entirely under the radar until just last month. Literally nobody knew who they were. Nobody knew what they were doing. And now they are stepping out of the shadows and directly into, the brightest spotlight imaginable. With this claim that they've solved this decade-old problem in artificial intelligence, it's kind of like it's like they're the quiet kid in the back of the classroom, right? The one who suddenly stands up and just claims they've solved the impossible math problem everyone else gave up on.
Yeah, that's exactly what it feels like. And the psychology behind that kind of entrance is something we really need to examine, the whole, stealth mode startup thing.
Right. Why do it?
Well, maintaining absolute secrecy until you have a supposed game changer is a highly calculated strategic move, especially in the current artificial intelligence landscape.
But why stay hidden for so long? I mean, if you have a brilliant idea, wouldn't you want to plant your flag as fast as possible so nobody else takes credit?
Normally, yes. But not if your idea targets a fundamental bottleneck that the multi-trillion-dollar companies are, desperate to solve.
Oh, interesting.
Yeah, if you are a small team and you publish a white paper or, say, announce your novel approach too early, you invite a very specific kind of threat.
Which is what?
Well, the giants, your Microsofts, your Googles, your Metas, they have practically unlimited resources, right?
Right.
If you tell them the direction you are heading, they can immediately pivot an army of 10,000 engineers to explore that exact same vector.
Oh, wow. Yeah. They act as, fast followers.
Exactly.
They let you find the path, and then they basically pave a 6-lane highway over it before you can even finish walking down it yourself.
That is exactly it. They can outspend, outhire, and outcompute a startup on a Tuesday.
Yeah.
So you stay in the shadows to work without a target on your back. You incubate the idea until the intellectual property is completely secure and the mechanism is undeniably functional.
You wait until the moat around your business is just too wide for the big players to cross easily.
Precisely.
Right.
And the fact that Subquadratic stayed hidden until just last month It suggests a very deliberate, highly confident leadership team.
So, if hiding in Miami gave them the runway to build this massive moat, what exactly is the monster they were building in the dark? Because Subquadratic has stepped out of stealth mode to announce that they have cracked the code on what our source calls a mathematical bottleneck.
Yeah, and what's fascinating here is the precise language being used by the MIT Technology Review, a mathematical bottleneck.
Right.
It represents a fundamental hard limit on how we currently build artificial intelligence. Let's look at how large language models, the AI that powers everything from, everyday conversational chatbots to really complex enterprise text analysis. Let's look at how they've historically been improved over the last decade.
Well, the industry strategy has basically just been like bigger is better, right?
Pretty much.
If you want a smarter model, you feed it more data, essentially scraping the entire internet. And to process all that data, you throw an obscene amount of hardware at the problem,
Yeah, you buy hundreds of thousands of highly advanced processing chips.
which consume like gigawatts of electricity.
Right, and you just brute force the training process, right? But a mathematical bottleneck means that the limitation isn't your hardware.
Oh, okay.
The limitation is the fundamental physics of the algorithm itself.
Yeah.
In current AI models, specifically the architecture that almost every major company uses today, there is a mechanism that requires the system to compare every single piece of data to every other piece of data to understand context.
Okay, wait, let me try to break that down.
Right.
Imagine being at a party.
Right.
If you are the host and you want 5 people to all shake hands with each other, it's easy. That's just 10 handshakes.
Right.
But if you invite 50 people, it's not just 10 times the work. It literally explodes to over 1,000 handshakes.
Exactly.
Now, imagine a party with 50,000 people, which is roughly about the size of a short book. For every word in that book to sort of shake hands with every other word, to understand the context of the entire story, you are looking at over 1 billion connections.
Over 1 billion. Yeah.
The math just completely explodes.
And that party analogy perfectly illustrates quadratic scaling. As the size of your input grows, whether that's a longer document, a larger code base, or a bigger data set, the computing power and time needed to process it doesn't just grow linearly.
It doesn't just double if the data doubles.
No, it grows at an accelerating squared rate. It becomes exponentially heavier.
So you reach a point of like diminishing returns where throwing twice the amount of money, twice the electricity, and hardware at the model only yields a tiny fraction of improvement.
Exactly.
The math itself is what chokes the progress.
Yeah.
And that is what has stumped researchers. We literally cannot build enough power plants or manufacture enough chips to keep scaling up if the math stays quadratic.
Which brings us to the physical reality of the tech industry today. I mean, we are seeing power grids strained and billions of dollars poured into specialized cooling systems for data centers, all just to service this quadratic appetite. The entire global supply chain for semiconductors is currently bottlenecked by the need to feed this specific mathematical limitation.
And here's where it gets really interesting, actually. When I was looking at the source material for today, a massive clue was just sitting there hiding in plain sight.
Oh, yeah.
Look at the name of the company, Subquadratic.
Oh, yeah.
Subquadratic. If the problem is this quadratic math holding back scalability, naming your company Subquadratic sounds like a literal mathematical declaration of how you solved it.
Absolutely. Taking that a step further, the name functions as a sort of technical filter and a bold declaration all at once.
Right.
Only the engineers and researchers actively dealing with this specific multi-billion-dollar pain point truly understand the immediate implication of that word.
It's like a new airline naming themselves like faster than light aviation.
Exactly.
By calling themselves Subquadratic, they are literally announcing to the tech world, hey, we found a way to undercut the curve. We are operating beneath the quadratic penalty.
Yeah.
They are telling the giants they found a shortcut through the maze that everyone else thought was a solid brick wall.
Right. And to break a mathematical bottleneck of this magnitude means you haven't just engineered a slightly faster computer chip.
No.
You have fundamentally rewritten the foundational algorithmic rules that the entire artificial intelligence industry has relied on for nearly a decade.
Okay, let's pump the brakes for a second, though.
Okay.
Because it's one thing to have a clever, deeply nerdy name, right?
Hmm.
And it's another thing entirely to make a bold claim after hiding in a basement in Miami for a few years.
Fair point.
How is the notoriously critical AI community reacting to this?
Mhm.
Because scientists and researchers aren't exactly known for blindly trusting a slick marketing rollout.
No, they are inherently skeptical, and honestly, history gives them every reason to be.
Yeah, lots of hype in tech.
Exactly. The tech industry has a long track record of vaporware companies promising these revolutionary leaps that turn out to be nothing more than clever smoke and mirrors.
Right.
And our source notes that the initial details released by Subquadratic were incredibly sparse. They made the claim, but they didn't really show the underlying math.
Which naturally led to deep skepticism. It's the whole pics or it didn't happen mentality, right?
Yeah.
If you claim you solved the handshake problem with the 50,000 person party, you better have the mathematical proofs to back it up.
Yet, the MIT Technology Review Digest reveals a significant shift in the community's posture recently.
Really?
Yeah. It notes that Subquadratic's team is now beginning to share their findings with the wider AI world.
Okay.
The specifics of their approach are still firmly under wraps, but the excitement around the advancement is described in the digest as palpable.
Wait, I have to push back on this.
Okay, go ahead.
If the actual specifics, like the code, the mathematical proofs, the secret sauce, if all of that is still locked in a vault, why is the excitement suddenly palpable? Aren't these highly trained, skeptical scientists just taking a startup's word for it right now? That feels like a massive contradiction to how peer review works.
Well, if we connect this to the bigger picture of how proprietary tech breakthroughs are validated, the contradiction kind of resolves itself.
Okay, how so?
There is a profound difference between sharing your core recipe and sharing your empirical findings. Subquadratic is currently engaging in a process of black box validation.
Okay, break that black box process down for me. How do you validate something you literally aren't allowed to look at?
Think about it like a revolutionary new engine design.
Okay.
Subquadratic isn't handing over the blueprints to the engine that's their intellectual property, right?
Right, because of the fast followers we talked about earlier.
Exactly. If they release the blueprints too early, the tech giants will just copy the mechanics. So instead, what they do is invite independent researchers to bring their own fuel, put it in the engine, and rigorously measure the output.
Oh, so they provide APIs, interfaces, that allow the scientific community to test the model's performance without ever seeing the code itself.
Precisely. They allow researchers to throw massive, complex prompts at the system.
Okay.
And the researchers can measure exactly how many milliseconds it takes for the model to process the data, and they can calculate the compute cost in real time.
Oh, I see.
If you feed the model a 10-page document, and then you feed it a 1,000-page document, and the processing time scales linearly instead of quadratically, well, the math is proven by the physical output.
Wow. So the palpable excitement our source mentions, it doesn't come from blind faith at all.
No, not at all.
It comes from the stopwatch.
Yeah.
If the AI community is running tests and physically observing that the bottleneck is just gone during these performance benchmarks, that shifts the mood from deep skepticism to electric excitement really fast.
Exactly. They are watching the impossible happen on their own monitors, even if they don't yet understand the mechanics behind the curtain.
That is wild.
It creates a very specific kind of tension in the industry, too. It forces every major player to stop and pay attention, because if these empirical findings will hold up to sustained long-term testing, the entire landscape of computing is about to undergo a seismic shift.
Yeah.
The economic foundation of how AI is built and sold will be completely rewritten.
Okay, so what does this all mean for you, the listener? Let's assume Subquadratic's claims hold up to full scrutiny. Why should you care about a solved mathematical bottleneck in a lab in Miami?
Right.
We need to translate this from abstract algorithmic theory into the reality of daily life.
Well, the translation is actually quite direct, and it really comes down to the two most powerful levers in technology: time and money.
Okay.
If this breakthrough is real, it leads to significantly faster and vastly more cost-effective development of AI models across the board.
It's like the entire tech industry has been driving these hyper-advanced sports cars. But for the last 10 years, we've been completely stuck in first gear.
Yes, that's a great way to put it.
Because the special fuel required to shift into higher gears was just mathematically too expensive to produce. It would basically bankrupt a company to drive fast.
Exactly.
But Subquadratic claims they didn't just invent a new fuel, they invented a way to unlock all the other gears for pennies on the dollar.
Yeah.
The speed limit simply disappears.
And the ripple effect of that unlocked speed and reduced cost, it opens entirely new doors for innovation. We really have to look at the democratization of artificial intelligence here.
Right.
Because right now, training and running a highly capable frontier AI model is an oligarch's game. It requires multi-billion-dollar data centers and endless capital.
Yeah, the barrier to entry is astronomically high. A handful of massive corporations essentially control the future of the technology because they're the only ones who can afford the electricity bill.
Exactly. But if Subquadratic has shattered the mathematical bottleneck, they have drastically lowered that barrier to entry.
Wow.
If the compute cost plummets by an order of magnitude, AI won't just be the playground of trillion-dollar tech giants anymore.
So who gets to play?
Well, a small team of developers, a regional hospital system, or say, a local university could suddenly afford to build and run complex text analysis tools and hyper-specialized applications that were financially impossible to sustain just a few months ago.
You're talking about taking the analytical power of an enterprise-level supercomputer and making it financially accessible to everyday innovators.
Yes.
Like a local hospital could train a model exclusively on their own patient data to predict localized health trends without having to rent server time from a tech giant.
Exactly. It decentralizes the power. We will likely see a surge of highly customized, incredibly efficient AI tools entering the market.
Solving niche problems, right?
Yeah, solving niche problems in education, logistics, urban planning, the creative fields problems that the big tech companies might never have bothered to address because they just weren't globally scalable.
Right.
It shifts the entire paradigm of the industry from who has the most computing power to who has the most useful ideas.
That completely levels the playing field.
Yeah.
It takes a technology that was consolidating power at the very top and scatters it out to the edges.
It does. And it reminds us that in technology, the most profound changes often don't come from the loudest voices with the deepest pockets. They come from a fundamental rethinking of the underlying rules. Subquadratic didn't outspend the giants, they outthought them.
That is just incredible. Let's recap what we've unpacked today. We started with the mystery of Subquadratic, this stealth startup emerging from the bustling shadows of Miami.
Right.
They arrived on the scene, claiming to have cracked a decade-old mathematical bottleneck, the quadratic scaling problem that forces AI models to consume massive amounts of power and hardware just to comprehend context.
Yeah.
We explored how they navigated the tightrope between intense industry skepticism and the necessity of secrecy, ultimately proving their findings through black box testing. And that testing generated palpable excitement among researchers who watched the bottleneck disappear in real time. Finally, we looked at how this algorithmic victory could lead to vastly cheaper, faster AI, democratizing the future of technology and taking the power out of the hands of the few and giving it to the many.
It really is a remarkable narrative arc, all contained within the implications of a single news digest. I mean, the theoretical has suddenly become highly practical.
It really has. I want to thank you for joining us today to explore this cutting-edge development. It's a powerful reminder of the ever-evolving nature of technology and how quickly the impossible can become reality when someone simply looks at a problem differently.
Yeah, and this raises an important question to leave you with.
Okay.
If a small, under-the-radar startup can supposedly solve a mathematical bottleneck that stumped the entire multi-billion-dollar AI establishment for nearly a decade,
Yeah.
what other impossible technological barriers might be quietly getting cracked in a garage or small office right now?
Wow. The wall has a door in it now.
Yeah.
We just have to wait and see who walks through it next.
Yeah.
Until next time.